We're modeling a scenario with a trig function here. The depth of the water of a harbour is modeled by this formula. And what we're going to get when t is 0 is sine 0 is 0. So it's going to start at 5. Actually, it's going to go up and then back down. It's probably never going to go below 0. Yeah, because the minimum it would be -1. So the minimum it would actually ever be is 3. And the max, I mean, it's the question's not asking about this, but the maximum would then be 7. So it's going between these values. A boat enters the harbour at 6:30 a.m. So T is the number of hours after midnight. So it would have been kind of going up and down for a little while. It takes 2 hours to load its cargo. The boat requires the depth of the water to be at least 3.8 meters before it can leave the harbour. Right, but first of all, find the depth of the water in the harbour when the boat enters it. So 6:30 a.m., that's 6.5 hours after midnight. T is 6.5. And we can just sub that in. 5 plus 2 sine 30 times 6.5 gives us 4.4823, or 4.48 meters. The second part, we're asked to find the nearest minute, the earliest time the boat can leave the harbour, so when the water is at least 3.8 meters. Note, it enters at 6:30, takes 2 hours to load the cargo, so time is going to have to be greater or equal to 8.5. Okay, well, let's create an equation. I need the water to be increasing at the time rather than decreasing, but it should all be okay to figure out. So we want to solve actually 5 plus 2 sine 30t is equal to 3.8, which means 2 sine 30t is minus 1.2. So sine 30t is minus 0.6. I'm going to draw a little sketch of the sine graph. Okay, so let's try and find this solution here, maybe this one as well. We can do inverse sine of minus 0.6. Gives minus 36.869. So actually, that's that one there. In fact, it's the same distance away from 0 as this one is from 180. So I can do 180 plus 36.869, or equivalently 180 minus 36.869 to give us 216.689. Just going to also find the other one because that will be, in this case, 360. 360. Well, actually, I can just add 360 on to minus 36.869. That's going to be the best thing to do, I think. 323.13. Okay, so we can obviously ignore the negative. I should probably, let me just write this down here. So divide through by, reject that one, divide through by 30. So this one I get 10.771. I want to get to the nearest minute, so I might just add another one. Okay, this is 0. And then the 216.869, divide that one by 30. 7.22896. Now, a few things to say here. First of all, that 7.22 time is less than the 8.5, so they're still actually loading the cargo at that point. But also at that point, we're going to get to the 5 plus 2 sine 30t. It's going to be on the way down, so it's going to hit 3.8 at the 7.22, but then it's going to go lower, and it's only on the way back up um, then that is going to reach 3.8 meters again at 10.77. So the times below, so although there is a time period where it's above 3.8 meters, it's actually going to be, um, you know, when they're doing the cargo. The next time is they have to wait it out, and then it's on the way back up. We get to 10.77. So this is going to give us our answer. We just need to convert to minutes. So it's going to be 10 hours. And let's convert 0. So just then minus the I've lost it, but 10.771 minus the 10, because that's the basically the fraction of the hour left with. So to convert it into minutes, times 3 by 60, get 46.26. 10 hours, 46.26 minutes. And therefore the time correct to the nearest minute is going to be 10:46, and it's going to be AM. Okay, just have to be a bit careful with that last bit. I hope I've made sense. We do have to. I would strongly advise solving an equation. Just be really careful then, thinking about whether it's going up or down after it. You could, in fact, turn it into an inequality, but I feel like that's going to make it unnecessarily complicated. So, anyway, I hope you're happy with that. Well done.